Hello viewers, in today's class we are going to discuss two important and conceptual limits, right? And here these two limits are very conceptual and useful for the beginners, right? So let us start. So in the first limit we have to find limit x tends to pi minus, and here we have greatest integer of sine x, right? So here this negative sign shows that we have to find the left hand limit of this function, that is greatest integer of sine x. And in the second limit we have limit x tends to pi plus, and we have greatest integer of sine x. And here this positive sign shows that we have to find the right hand limit of this function, that is greatest integer of sine x. So here to find out the values of these two limits, we'll take help of the graph of sine x, right? So let us first take the rough diagram or the rough graph of sine x. So here we have the graph of y is equal to sine x, right? So here we have 0, and here we have pi, right? And here we have 2 pi, right? So this is one complete cycle of sine x, right? And we know that the maximum value of sine x is plus 1, and the minimum value of sine x is minus 1, right? And here we have pi by 2, and here we have 3 pi by 2, right? So this is the graph of y is equal to sine x. So now let us first take the this limit, that is the limit x tends to pi minus, and here we have greatest integer of sine x, right? So let us denote this limit by L, right? So now here what we will do, we'll take x is equal to pi minus h, right? Where h is a positive quantity and it is greater than 0, right? So when x tends to pi minus, then h tends to 0, right? So now this limit L can be expressed in terms of h as limit h tends to 0, and we have greatest integer of sine pi minus h, right? So here we have taken x is equal to pi minus h. Now see, we have this limit in terms of h, and here we cannot directly substitute h is equal to 0, right? So what we will do, we'll try to find out the value of this expression, that is greatest integer of sine pi minus h, right? Now see, here the angle is pi minus h. So now here the angle is pi minus h, right? So what we will do, we'll take a point which is in the neighborhood of x is equal to pi, right? So here we have pi, so we'll take a point in the left neighborhood of pi. So let us take this point as a, right? And this point a is pi minus h, right? And now if we draw a line which is parallel to y-axis, then we have this line, right? And now if we take a line which is parallel to x-axis, then we can draw it like this, right? So now here we have some point, say C, right? And this is 0, or we can take it as this point as O. So OC is the value of sine pi minus h, right? And we can easily see that this distance, that is OC, which represents sine pi minus h, it lies between 0 and 1, right? Because this point is 0, which is the origin, and 1 is the maximum value of sine x, right? And C lies between 0 and 1. So OC lies between 0 and 1. So it implies sine pi minus h, it lies between 0 and 1, right? And by the definition of greatest integer function, the greatest integer of sine pi minus h is equal to 0, right? Because this quantity, that is sine pi minus h, it lies between 0 and 1. And from the definition of greatest integer function, we know that if some number p, it lies between 0 and 1, then the greatest integer of p is 0, right? So now the greatest integer of sine pi minus h is 0. So we have limit h tends to 0, and here we have 0, right? So this is equal to 0. So the value of limit x tends to pi minus greatest integer of sine x is equal to 0, right? Now let us take the second limit. So now let us denote this limit by r, right? So the right hand limit, that is the limit x tends to pi plus, and here we have greatest integer of sine x, right? So to evaluate this limit, now what we will do, we'll take x is equal to pi plus h. Now in this case, we'll take a point to the right neighborhood of x is equal to pi, right? So again, h is positive and h is greater than 0. So when x tends to pi plus, then h tends to 0, right? So now here we'll take a point in the right neighborhood of x is equal to pi, and let us take this point as b, right? So now if we draw a line which is parallel to y-axis as we have done in the first case, then we'll have a line like this, right? So now this is a line which is parallel to y-axis. Now if we take a line which is parallel to x-axis like this, then this point, that is, say this point is D, right? So OD now represents the value of sine pi minus, that is pi plus h, right? So now this distance OD, it represents sine pi plus h, right? So OD, it is greater than minus 1, but it is less than 0, right? So for OD we can now write sine pi plus h, right? And this quantity is greater than minus 1, but it is less than 0, right? So we know that if any quantity p, it lies between minus 1 and 0, then the greatest integer of p must be equal to minus 1, right? So now the this limit r can be written as in terms of h, that is limit h tends to 0, because when x tends to pi plus, h tends to 0, and here we have greatest integer of sine pi plus h, right? And we have just seen that the value of sine pi plus h, it lies between minus 1 and 0. So the greatest integer of sine pi plus h must be equal to minus 1, right? So here we have minus 1, so this is equal to minus 1, right? So the value of this limit is equal to minus 1. So viewers, from this discussion, we have seen that uh, the limit of this function, that is greatest integer of sine x, when x tends to pi, the right hand limit is minus 1 and the left hand limit is 0, right? So the right hand limit is minus 1, the left hand limit is 0, and both the limits are not equal to each other, right? That is, right hand limit is not equal to left hand limit, that is minus 1 is not equal to 0, right? So we can say that the limit x tends to pi of greatest integer of sine x, this does not exist, right?